All right, this is 5.1. I've been asked to do a few problems here, so I'm going to do them for you. The first one is number 6, and you'll we need a calculator. So we want to be able to use mean value theorem in order to solve this. So in order to do that, we've got to find the slope between these two endpoints. So first of all, I should say that f is continuous and differentiable. Actually, I should say continuous on 0 to 6 with brackets, and differentiable on 0 to 6, or 0 to pi over 6, sorry. There should have been pi over 6 over here too. And differentiable without the endpoints because you can't do a derivative at the endpoint. Because there's no x in the denominator, I know it's continuous. And I also know a sine curve is a smooth curve. So no matter what I add or subtract from a smooth curve, it's going to stay smooth. So I know this is true, so now I can use the mean value theorem. So I have to find f of 0. So to find f of 0, I'm going to get 6. And I would think of this as 6 over pi times 0. I'd move the x over for when I do the derivative. And then minus 4, and then this is sine of 0 squared. So hope you all know sine of 0 is 0. So this is all 0, and 0 times anything 0, so that's 0. And then I have to do f of pi over 6, the other endpoint, which is going to be 6 over pi times pi over 6. I think I can reduce that one. Minus 4. And then I got to do the sine of pi over 6 squared. So I got to figure out what pi over 6 is. Well, if you don't know, in the unit circle, pi over 6 is here at 30 degrees. So my ordered pairs are radical 3 over 2 and 1/2. Sine is the y, so that's a half. So this right here all reduces to 1 minus 4. And then I got 1/2 squared. Well, if I square a half times a half is a 4. So this is 1 minus 4 times a 4. And then these reduce, so this equals 0. So if you look, this y is 0, that y is 0. So this is actually Rolle's theorem. So when I do the slope of this, I get 0 minus 0 over, I'm going to put pi over 6. Pi over 6 minus 0 is 0 over pi over 6 is 0. So there's my slope, and this is supposed to equal the derivative of this thing. So I need to find the derivative of this. So I'm going to do the derivative of this thing. And remember, I'm thinking of this as 6 over pi x. So that's going to be 6 over pi. The derivative of this is 6 over pi minus, keep my coefficient the same. Now I have to do chain rule. So I've got to take that 2. Okay, so I'm going to take that 2 out front. So that would actually become minus 8. I'm going to leave the inside the same, sine x. And then it's going to be the derivative of sine x, which is cosine x. And that would be my derivative. And I'm trying to find when that equals 0 because I want the derivative to be 0. Now I'm looking for x. Now, if you want to put c's in here, you can put c's in here because they show you c's here, but I'm just going to leave it x. So what I'm going to do is I'm going to let this thing on my calculator be y1. And I'm going to let this thing, actually, I don't even need to do that because 0 is the x-axis, so I'm going to be looking for zeros. So I'm going to take my calculator, move this thing over here, turn this on, I'm going to go to y equals, I'm going to clear these off. Now I'm going to put that derivative in there. So I'm going to have alpha y equals 1. I'm going to have 6 over pi. And then come over here and have minus 8 sine x cosine x. Now I'm going to graph this thing. Now, if you notice up there on the screen up here, this says 0 to pi over 6. So I'm only worried about that. So I'm going to change my window from 0 to pi over 6. Now, I put in there pi divided by 6. That shows pi over 6 there, but when I hit enter, it is going to go into a decimal form. So there's what I'm looking. I'm just looking from 0 to 0.523598776 is all I'm looking for on my screen. And I'm going to hit graph. Now I'm looking for where does this cross this x-axis? Where does it equal 0? So I can see it crossing right there. And let's see if that's the only place. It looks like it's going to be. So it's done graphing. So I'm going to hit second calc, and I need 0. So I hit 2. And I got to get on the left side of where it crosses. So I need this to be a positive, which it's positive right now. So I'm going to hit enter. Then I got to get a negative. So there it just went to a negative. I'm going to hit enter and enter again. And there's my answer, 0.249. So x is about 0.249 is where this is true. So that is the x coordinate, which we could also call this c if you want to use c's in here. So either way is fine. So that is how you do number 6. So the next one that was asked to do was number 14. So let's go find number 14. Oh, did I pass it? Yep, I just passed it. Let's go back. So we're going to do this number 14, which is also a calculator, and it's going to be done almost identically the same way, except it may not be Rolle's theorem. So let's see. So we got to find the endpoints again because I want to get my slope. And again, hopefully you notice that none of these have a variable in the denominator, so this is continuous from 0 to pi, of course, and differentiable. So we get to say f is continuous, and when it's continuous, we use the endpoints, and differentiable. And when we talk differentiable, we don't use the endpoints again because you cannot do a derivative at the endpoints. So then we're going to find f of 0. So I'm going to plug zeros in here. 2 cosine of 0 plus cosine of 2 times 0, which is still 0. 2 times 0 is 0, and that's 0. So let's see, this is 2 times 1 plus 1, which is end up being 3. So that ordered pair is 0, 3. And then I need to find f of pi. So that's going to be 2 cosine and pi plus cosine of 2 pi. Okay, so pi is 180 degrees. That's where that's negative 1. And then 2 pi is over at 0 again, so that's positive 1. So let's see, negative 2 plus 1 is negative 1, so there's my other point. So I need to get the slope of these. So I get 3 minus negative 1, the change in the y's, over the change in these x's. 0 minus pi, so this is going to be 4 over negative pi, so negative 4 pi, 4 pi's, negative 4 over pi. So that is going to be my slope. And then remember, we're looking for where does the, oops, I want it up there, I want it down here. Where does the derivative, okay. Oops, I got the wrong thing. Let's see. Okay, my button must be stuck. There we go. Where does the derivative of this thing equal negative 4 over pi? So I need to do the derivative of this. So this first one is just a straight up 2 stays in front, and then the derivative of cosine is negative sine. So I'm going to put sine x and a negative here. And then I got to do the derivative of cosine of 2x. Well, cosine is my original, so that's going to be a negative sine of that of 2x. And then you have to do the derivative of 2x because it's chain rule. I got to put a 2 here. So I am looking, my goodness, that's not very easily read. There should be a 2x. Keep the angle the same, and the derivative of it's at 2. And we're looking for where does that equal negative 4 over pi. So I'm going to stick this thing right here into y1. I'm going to stick this thing right here into y2. And then I'm going to see where those intersect. And remember, I'm only worried about from 0 to pi. So I'm going to come back to my calculator, and let me put my calculator back up on the screen. Okay, so I'm going to get rid of that last problem. And I'm going to put negative 2 sine x minus 2 sine 2x. So that's my first one. And then I'm going to come down here to this one and make this negative 4 over pi. Okay, and now remember my window, I'm going now from 0 to pi, so I got 0, which is already there, and then down here I'm going to hit second caret, which is pi, and that's again, so I'm going to go to decimal. So I'm only looking from there to there, and I'm going to graph those. So here comes my -2 sine, -2 sine 2x graph. So there's a place it crosses, and there is another place it crosses. So looks like, and there's the -4 over pi line, the red one. So there's two places that this works. So I need to use both of those. So now I want an intersection. So I hit second calc 5. I'm going to come way back over here to this first one. And all I got to do is get close. If you notice it's on the blue one and tells me blue is that one of them, the answer is yes. You hit enter. Now it jumps to the red one. You hit enter, and you hit enter a third time. So my first answer is 0.217. 0.217. So let me write that one down. And again, you can use C or X. So X is about 0.217 is one of the answers. And then we're going to get another one because it crossed twice. So let me get my camera back up. So now I got to hit second calc 5 again, but now I got to bring it way over there to the other intersection or by it. It's getting closer. Close enough. I'm going to hit enter, enter, enter. And my other answer is 1.748. So this has two answers that work. Both of these work by mean value theorem. Okay, and then I was asked to do one more problem, and that problem was number 17. So let's go over here and do 17, which I did earlier. So I'm just going to explain to you what I did here. Now maybe I should go ahead and do this. So anyway, there are two places that x can't be here. If you look at this, x cannot be 0 because 0 here, 0 there makes 0 in the denominator, and x plus 3 can't be 0, which means x cannot be -3. Well, if you look at the interval we're looking at, 3 to 6 doesn't matter. So neither one of these are on 3 to 6, so this graph is continuous. So I should have said C is continuous. I didn't write that in the last class, on 3 to 6. And we can do the derivative of this. And differentiable on 3 to 6 with parentheses. So I'm going to do this one differently. I'm going to type this thing in right here, and I'm not going to even do the derivative by hand on this one. So what I did was, I'll just show you, on my calculator, I typed in that problem. I'm going to move this over so I can see this equation right here. Clear this off. I could have done this on the other problems too, but I'm going to type in that 10,000, just like it shows, parenthesis, and alpha y equals 1 to get a fraction bar, and put 1 over x in. And arrow to the right and put, I think that's a plus. I have to get it on my screen closer to me because I can't see it. Yes, it's plus. I'm going to type in plus, and then I've got alpha y equals 1 again. And I'm going to put x over x plus 3. And then there's my graph. So now I'm going to look at this graph. Well, I got a problem here. I'm going to go back from -10 to 10 on my graph. And we're going to see you cannot see this graph. Well, if you notice in the problem over there to the right over here to the right, you got 10,000 times something. So that's a pretty big number. So what I'm going to do is I'm going to change my y value. I'm going to window. And let's see, we're going from 3 to 6. So I'm going to change this from 3 to 6. And I'm going to change that to 10,000 because I want it to be on there. I think that'll probably work. So there's the graph way up high. Okay, so there's that graph. And now I want to find out what the value at 3 is because I need the endpoints. Okay, so I'm going to hit second calc 1 and put in 3 and hit enter, and there's that 8,333.3 repeating, which I wrote on the screen there. And then I'm going to hit second calc a value again, 1, and I'm going to put in 6 because that's the other endpoint. I get the exact same thing. So this is Wohl's theorem. So that when I do the difference, you look up here and I do the difference of 8,333 and a third minus that, you're going to get 0 over 6 minus 3. That's 0 over 3. So that's why I put a 0 here, because the slope between these 2 points is 0. And I want to find where the derivative of this thing equals 0. So what I'm going to do is I'm going to graph the derivative of this. So I'm going to do that on my calculator. So if you remember, I want the derivative of that thing right there. So I'm going to come down here and I'm going to hit Math 8, which I could have done on those other problems, and I'm doing X. Now I want to put this equation in there, so I need Y1, so I'm going to hit bars. I'm going to arrow to the right to Y bars, and then 1, and it's in Y1, so I hit 1 again, and then I'm going to graph it so that it's X to X. Okay? Now, I'm going to graph this, and then I'm going to change something, because I don't know if you're going to be able to see it or not, but way down here at the bottom, this is going to come in there in red in a minute. If you look up here, this thing's still turning. That means it's still graphing. And when you graph a derivative, it takes a while. So right now, there's a little bit of red showing down there. I don't know if you can see it or not, but there's some red of this showing. Now, I can go ahead and find this thing, or I can make this graph so that I only look at the red one. So I'm going to make it look a little nicer for me. So if you look, that goes through the x-axis, right? So what I'm going to do is I'm going to go y equals, and I don't need that top graph anymore, so I'm going to shut that off. And then I'm going to hit zoom 6, which will go from, oops, wait a minute, I want to stop that. I want to go back to my window. Instead of going -10, -10, I want to just look from 3 to 6. So I'm going to go 3 to 6 and hit enter. And then I'm going to graph that, and there should be somewhere in there that red line is going to cross the x-axis, because we could see it on that bigger graph. But this is going to make it real easy to see or to find it when we do the 0. And that little circle is still spinning out there by my battery life. And we should start seeing a red line. There it is. So there it goes through right there. And that is the only answer that works from 3 to 6. Now, if my screen was different, this also works over on the negative side. This graph hits over there too. But I don't want that. So what I'm going to do is I'm going to find that 0 as soon as that little circle stops spinning, because I can't find it till the circle up here stops spinning, because it's still graphing it. And again, this takes forever when you do a derivative on your calculator. So maybe we should have done the derivative by hand, because it is still graphing. Okay, now it's done. So I hit second calc 2. And if you look, I'm way up here at 39, and I got to get down here where I can see it. So I'm going to arrow to the left, and you can see this value is coming down. And now I can see my cursor. I got to get below it, hit enter, go above it, hit enter, and hit enter again. And there is my answer, 4.098764, and that's where this number came from. Where's my pen? Right here, there's that number that I found on the calculator right there. And then something we need to realize is that this says that this number is in hundreds. So we got to take that times 100, and if I round that to that's 409.8 bottles. So I should probably round that to about 410 bottles would be the order size, approximate order size for the bottles of Pepsi. So I hope you have a great day, and I will talk to you tomorrow in class.